First law of thermodynamics. At the end of this lesson, you will be able to state the first law of thermodynamics, illustrate the first law of thermodynamics, explain internal energy and enthalpy. Law of conservation of energy. The energy can be neither created nor destroyed. It can only be transferred from one form to another form.
Blabbermouths! Energy cannot be destroyed, only can be converted. I'm going to break this universal energy law. Let us see how the spring converts my energy. I proved it. My energy is not converted.
Energy cannot be destroyed. It can only be converted. When compressed, the spring stored elastic potential energy and released it. The energy can be of different forms. Heat energy, a form of energy which transfers among particles in a substance by means of kinetic energy of those particles. Electrical energy is the energy due to electron flow. Mechanical energy is the energy stored by a machine that induces motion. Chemical energy is the energy that bonds atoms in a molecule. From the conservation law, these energies can be converted from one form to another. Let us discuss these changes. The heat energy from the sun is absorbed by plants and is converted into chemical energy through photosynthesis. It is a natural process. And let us see few examples for artificial energy conversion processes. The conversion of electrical energy to mechanical energy in case of fan. Conversion of electrical energy into mechanical energy in home appliances like mixer, grinder, etc. The water heater is the good example for conversion of electrical energy into heat energy. In IC engine, there is a conversion of heat energy into mechanical energy. Conversion of chemical energy into heat and sound energy in crackers, and conversion of chemical energy to electrical energy in the battery. Moving further, another important classification of energies is potential and kinetic energy. Say a rock at some elevation possesses some potential energy. A part of this potential energy is converted into kinetic energy when it falls down. This energy conversion is called as first law of thermodynamics. One best example for chemical, heat and mechanical energy conversion can be found in the working principle of steam locomotive engine. Let us have a close look into the conversion of these energies. Here, the chemical energy of the fuel is converted into heat energy when they burn. Let us denote the heat energy supplied by burning of this fuel as Q. Generally, the unit for heat is joule. And this heat energy is used to boil the water. Let us consider the initial temperature of water as T1. If we see at microscopic level, the water molecules will have rotational, vibrational and translational movements all together, called as kinetic energy. And these atoms, when bound together, the binding energy of the atoms is the potential energy of these water molecules. This potential and kinetic energy combined together is known as the internal energy of the water molecule. Thus, internal energy can be defined as the sum of all microscopic forms of energy of a system, and the internal energy can be denoted as U. At initial level, Let us denote it as U1. When the water is heated, the water is converted into steam and these bonds are broken and the water molecules start moving vigorously. This leads to increase in the internal energy. At this stage, the internal energy can be denoted as U2. During this process, the temperature has increased from T1 to T2. Let us denote the change in temperature from T1 to T2 as delta T. And the change in the internal energy from U1 to U2 is denoted as delta U. This change in the internal energy delta U depends upon the quantity of water and its specific heat capacity, that is, the heat required to increase the temperature of water by 1 degree Celsius, and also changes in temperature delta T. Thus, the change in the internal energy delta U is the product of mass of water and specific heat capacity and change in temperature. Now, the supplied additional heat is used to expand steam to push the piston in the steam engine. And thus, the total heat supplied is used to increase the internal energy and also to do work, that is W. Now, the total heat supplied Q is equal to delta U plus W. Work can be defined as the quantity of energy transferred from one system to another, and the work is measured in joules. Let us see the total heat content of this system, which is the sum of total internal energy U and work done W. As the internal energy and work are two different properties that occur frequently together, it has been added to give a combined property known as enthalpy or total heat content. This total heat content of the system is denoted as H. Work done can be given as the product of pressure and volume. From the first law of thermodynamics, that is, energy can only be transferred. The chemical energy of a fuel is converted into heat energy, which is then converted into mechanical energy that helps the locomotive steam engine to move. Summary.
Everyone must be knowing the first law of thermodynamics. But I know it better, so I will take the responsibility to summarize it. First law states that the energy can neither be created nor destroyed and can be converted from one form to another. Internal energy is the microscopic level energy, which is the sum of all kinetic and potential energies, and it is denoted as delta U. Enthalpy is the total heat content of a system, that is, the total internal energy and work done. It can be denoted as H, where product B and V indicates the work done by the system.